In this video, we're going to talk about spheres. So what is a sphere? A sphere is a solid in which each point is equidistant from a center point. So it's very similar to the definition of a circle, because wherever your center is, the points are equal distance. That's what it means. So the great circle, which is right here, it slices a sphere into two hemispheres, meaning like two halves of it. So here's your diameter, the center point, and the radius. Here is our formulas for a sphere and the surface area, and here's the hemisphere. Notice it's not the whole sphere, it's cut, and that's the volume, and that's the surface area. We're going to go ahead and just use these formulas. So find the surface area and volume for each one. So first, let's go ahead and write the formula that we need for surface area. So the surface area equals, for the sphere, 4 pi r squared. And now I'll just plug in what we have. 4 pi, and I need a radius. So let's check. This 24 millimeters, that is not the radius, that's the whole thing, which means that's a diameter. So if my diameter is 24, remember the relation with the radius, it's half of it. It's from the center to that point, or from this center to that point. So the radius, you just divide it by 2, you get 12. So now I have 12 squared. Now do order of operations. Go ahead and do your exponents first. So we have surface area equals 4 pi, 12 squared will give you 144. And now you just go ahead and multiply all these out. So your surface area is going to equal to 1,809.557, blah, blah, blah. And I'm going to round to the nearest hundreds. So it's right here it stops. So because the number afterwards is 5 or greater, we're going to round up. So the surface area for this sphere is 1,809.56. And now make sure you add your units in there. It's millimeters squared because we're dealing with surface area. You always square with area. Now the same problem, let's go ahead and do volume. So volume is 4/3 pi r cubed. So now we know what our radius is, so we're good. 4/3 pi r is 12, and then cubed. Do your exponents again. So your volume is going to be 4/3 pi, and you have 12 cubed will give you 1,728. Now, all this can be done in the calculator. Now, if you're worried about this fraction, like it looks, what do I do with it? Don't worry about it. Just remember, this is all over 1. So you could rewrite this and do 4 times pi times 1,728 and then divide by 3. So let me show you. Like you'll have, multiply them out, you have the volume. I'm going to multiply 4 times 1,728, and you get 6,912 pi, and it's all divided by 3. That's the same thing. You're multiplying all this, and at the end you're dividing by 3. So once you do that, your calculator, you're going to get the volume, 7,238.229, blah, blah, blah. I'm going to round to the nearest hundreds again, so 2 decimal places, so that's going to round up. So the volume for this sphere is 7,238.23, and units, the volume is cubed. So we cube our units, 3D. Next, this is a hemisphere. It's not the whole sphere, so we're going to use these formulas over here to find the surface area and volume. So my surface area for a hemisphere is 3 pi radius squared. So let's ask, do we have a radius? Let's see. From the center to a point, yes, this is your radius. So now we're good to go. We just substituted in our value. 3 pi, your radius is 14 squared. So let me bring it over here. Do your exponents, 14 times 14, that's going to give you 196. Then we multiply 3 times pi times 196. So the surface area is going to equal to 1847.25, blah, 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 and it keeps going. Again, just this one didn't specify in directions where to round to, but if it does, just make sure you follow what they're saying. I'm just going to always round to the nearest hundred. So after the 5, I'm going to be rounding up. So my surface area for this hemisphere is 1,847.26. And my units are in yards, yards squared. And now we're just going to use the formula for the volume of a hemisphere. So it's 2/3 pi r cubed. Substitute in your values. Radius was 14. So same routine, you're going to do your exponents first, which is going to be 2,744. Now right at this step, if you want, just extend your fraction. Because that way you know you're multiplying everything and dividing by 3. So I'm going to multiply 2 times the 2,744. So I'll get 5,488 pi divided by 3. So when you do all that, your volume is going to equal to approximately 5,747.0201, blah, blah, blah. So again, I'm rounding to the nearest hundred. So I'm going to have it at 5,747.02 yards, but it's going to be cubed because it's dealing with volume. So pretty self-explanatory. Just make sure if you have a sphere or a hemisphere, whether you have a diameter or a radius, and you just substitute in your values, and all you're doing is multiplying everything and then dividing by 3, and same thing for here. Now let's get some problems, like word problems. Which ones will you get with that? A hollow sphere sits snugly in a foam cube so that the sphere touches each side of the cube. Find the volume of the foam. Okay, so let's make sure which one is the foam. A foam cube. So we're looking for the volume of the foam, which is the cube. But because there's a sphere inside, we didn't know, okay, what it's going to be if we took out that sphere. Like, what's the whole volume? So if you want the volume of the cube, because that sphere is inside, we're going to subtract it. We want to take that out to see what's really inside of that. Okay, so let's first find the volume of the cube. And it is a prism, so you can do like length times width times height. But because a cubed, see it's a square, they have all the same sides, it's your sides cubed. Because you're doing 18 times 18 times 18, so might as well just do 18 cubed. So the volume is 18 cubed. So when you get that, the volume of the cubed is 5,832 inches cubed. Okay, now let's find the volume of the sphere. So the formula for the volume of the sphere was 4/3 pi r cubed. So when you do volume of the sphere, all you need is a radius. Now, when I look at this, it doesn't really give me a radius or a diameter. So let's go back to our problem. Let's see if there's anything they said that could help us. A hollow sphere is snugly in a foam cube, so the sphere touches each side of the cube. That's important. Sphere touches each side of the cube. So that means there's no wiggle room. There's no space. Like the edges touch, the edges of the cube are touching just where the sphere is. So that means if this whole thing is 18 inches, that's what the diameter is. So the diameter is 18. So that means my radius is half of it. That would be 9. Okay, all because they told us that in the instructions. Well, directions actually. So we have 4/3 pi, your radius, cubed. So like we've been doing, do the exponents first. So 9 cubed will be 729. It's being multiplied. So at this point, go ahead and just extend your fraction. Because you're going to do 4 times 729. You get 2,916 pi. And then you're dividing by 3. So pretty simple. Multiply, put this in your calculator. I'm going to round to the nearest hundred, so it's going to be approximately 3,053.63 inches cubed. So that's the volume of the sphere and the volume of the cube we just found. So you want to find the volume of the foam. The foam is the cube. So like I said, you're going to subtract the sphere, take out the sphere out so you can see what is the volume of the cube because that's inside of it. So all we're doing is going to do volume of cube minus volume of sphere. So we're going to have the 5,000. So we have 5,832 minus what we just found. So when we get that, we will have 2,778.37 inches cubed. That's the volume of the foam. And lastly, example 4. You're going to see it's the same like routine, like substituting your values and stuff. Alrighty, so this one has a lot of words, so let's read this and highlight or underline that's important. So DC Sports Inc. ships sports balls around the DC Sports Inc. ships sports balls around the world. A bowling ball has a diameter of 8.5 inches. A basketball has a circumference of 29.5 inches. A softball has a circumference of 12 inches. A golf ball has a diameter of 1.7 inches. Determine which package of balls has the most volume. Is it 1 bowling ball, 1 basketball, 4 dozen golf balls, or 50 softballs? Justify your answer. So reading this is a lot of information, so let's break it down. So we know there's a bowling ball. Bowling ball has a diameter of 8.5 inches. Next, there's a basketball. The basketball has a circumference of 29.5 inches. Then there's a softball. The softball has a circumference of 12 inches. And lastly, you have a golf ball, diameter of 1.7 inches. So this is all important information. And what are we looking to find? We're looking to find which package of balls have the most volume. So that means I'm looking for volume, and all these shapes are balls or spheres. So that's what we're going to be using. So we're going to be using volume equals 4/3 pi r cubed. That's the goal. And now I'm just going to color coordinate with like the packages. So there's going to be 1 bowling ball. There's 1 basketball. But then there's 4 dozen golf balls. So 4 dozen golf balls. And there's 50 softballs. So that's what we have to keep in mind. That's why it's always good to read the question, because you might just be finding the volume of each sports ball, but you didn't realize the packages. So just make sure you're reading carefully. So let's do one thing at a time. Let's go ahead and find the bowling ball. We're finding the volume of each one. Bowling. Okay, so since we're finding the volume, I need the radius. The bowling ball has a diameter of 8.5 inches. So that's given. The diameter is 8.5. So radius is half of that. So your radius will equal to 4.25. And now you go ahead and just plug it in your formula. So go ahead and cube your 4.25. And it will be a decimal that keeps going, so I'm just going to round it. And then remember, you could just put this all over one fraction, multiply, then divide by 3. So the volume of the bowling ball, and you can just go ahead and do it all on your calculator if you think about it. Do 4.25 cubed times pi times 4, and then divide by 3 at the end. So the volume of the bowling ball is 321.56 inches cubed. The package of bowling balls is 1 bowling ball, so we're good. That's the bowling ball. Now we're going to do the basketball. So for the basketball, it tells me that it has a circumference of 29.5. Circumference. So let's go back. So that's what we're looking for, circumference. There's two formulas for circumference, which is like kind of the same thing. You could either have the circumference equals your pi times diameter, or the circumference equal to 2 pi r. So the circumference relates to the great circle, like we were talking about on the first page, okay? So either formula will do, but think about it. I need my radius, so I might as well use this formula. That way I could just solve for r instead of finding diameter and then divide by 2, you know? So I'm just going to use this one. So circumference equals 2 pi r. So because my circumference is equal to 29.5, I get this. And I'm trying to solve for my radius so I can use it for the volume. Remember, pi is just a number. So it's 2 times a number equals, not equals, 2 times a number times r. So if I want r by itself, I'm just going to be dividing the 2 pi. There's a reason why I'm putting in parentheses. When you put in your fraction, not your fraction, when you put in your calculator, you do 29.5 divided by and open your parentheses. That way you can do 2 times pi. And close your parentheses. So your radius is going to be approximately, so it's like 4.695, and I think it keeps going. So then your radius, let's just round it to the nearest hundred, will be 4.70. I'm just rounding everything to the nearest hundred. Alrighty, and now you just plug in the formula. 4/3 pi r cubed. Now because it's 4.70, I'm not going to put this 0, I'll just do 4.7 cubed. So go ahead and do 4.7 cubed. So then multiply by pi times 4 divided by 3. So your volume is going to equal to 434.89 inches cubed. Alright, so basketball is done. Now we have the softball. Oh wait, before I move on, you'll need 1 basketball, so we're good. Okay, so now softball. So the softball has circumference, the same thing. Circumference here will be 12, so the same style like this. I want to find the volume of it, so I need radius, so I'm going to go ahead and do circumference equals 2 pi r. So this will be 12 equals 2 pi r. I want to solve for my radius as being multiplied by 2 pi, so I'm going to go ahead and divide. So make sure you put parentheses on your calculator when you're dividing. So your radius will equal to 1.9098, blah, blah, blah. So nearest hundredths, it's approximately 1.91. And now let's substitute it in the formula. Radius is 1.91 cubed. To do 1.91 cubed times pi times 4, and everything's being divided by 3. So your volume is going to equal approximately 29.19 inches cubed. And the question is asking, there's 50 softballs, so that's just the volume of 1. So if there's 50 of them, all we're going to do is just do 50 times that volume we just received. So the volume of 50 softballs, remember we're talking about the pack. The pack will have 1,459.5 inches cubed. That's the total volume for 50 softballs. And the last one is the golf ball. So the golf ball, they gave me a diameter. So diameter here is 1.7. So I, again, need the radius. So I do half of that. So half of 1.7 will be 0.85. And let's substitute in our formula. So do your 0.85 cubed, then multiply by pi by 4, and at the end divided by 3, because remember you're just extending that fraction. So your volume is going to equal to 2.57 inches cubed. But remember, there's still some information. The package for golf balls, 4 dozen. So a dozen is 12. So if you have 4 dozen, you're just multiplying by 4, so that's 48. But just to show you, you're having 4 of your dozens, that's why you get 48, and then multiplied by your volume. So your volume is 123.36 inches cubed. And before we added like the packages, if you just looked at just the volumes that we got originally, it makes sense. The golf ball is the smallest ball, so that's why the volume is the smallest before adding the multiplication of 4 dozens. Okay, so now we have everything. We have 321.56, that's the volume for 1 bowling ball. For 1 basketball, we got 434.89. For softball, we have 50 softballs, it's 1,459.5 inches cubed. And then for the golf ball, 4 dozen golf balls is 123.36. So, as you can see, the one with the most volume is the softball. So the answer is softball. Softball has the most volume. Can't really to justify is because that's the largest volume you have compared to all of them. Okay, so the answer is softball. And that's how we do problems involving volume and surface area of spheres.